Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 16 of our complete DevOps course. In the previous classes we talked about configuration management, we talked about Ansible, and yeah, I know few of you have doubts with respect to dynamic inventory. That is something that we did not talk in the previous class. So with your request, what I've decided is, yeah, I'll make a completely dedicated video on dynamic inventory and I'll make sure that all your doubts are cleared. But for today, we'll be talking about infrastructure as code. Okay. So today's topic is infrastructure as code. And in today's class, we'll completely talk about the theory part. By theory, I mean to say, we'll try to understand what is the problem, right? Because first of all, we need to understand what is the problem. And then we'll see what are the use cases, and finally we'll try to understand what is the solution. Okay, so without wasting any time, let's quickly start the video and try to understand infrastructure as code. Now let's say that you are a DevOps engineer. Okay, so you are a DevOps engineer who is working for an organization called let's say Flipkart. Okay, so you're working for Flipkart. So Flipkart as a company, they can create their compute resources anywhere, right? So what is a compute resource? Compute resource is nothing but CPU, RAM, or any other hardware resources. They can create on any of the cloud platform, or they can also create on their on premises. That is, Flipkart has let's say 300 applications. Okay, so to deploy these 300 applications, they would need servers, because servers is a player where you deploy your applications and expose to the customers. Now, Flipkart can deploy these applications on different options. Like they can deploy these applications on AWS, or they can deploy these applications on Azure, Google Cloud Platform, or they can also deploy it on their physical servers, that is on premises, right? And there are bunch of other options. These are not only the four options. Okay, this can exceed, like you have Oracle Cloud, you have DigitalOcean, hundreds of options are there. So as a DevOps engineer, let's say you have decided that, okay, you evaluated all of these things and you said that, okay, so Flipkart will host all of their infrastructure on AWS. Okay, so let's say as a DevOps engineer you have taken this decision, and this decision went very well, and what you have done is, you started to create servers on, like, it can be EC2 instances, or it can be S3 buckets. Okay, or it can be RDS database. All of these resources are required for your organization, and as a good DevOps engineer, what you have done is you have automated the entire process on AWS. Like, instead of creating manually through the console, what you have decided is you will use the AWS CLI. Okay, or you can also use something like AWS cloud formation templates. Okay, CFT, let's say cloud formation templates as CFT. So in the previous class when we talked about AWS automation, I already mentioned you, like, there are multiple options. You can use AWS CLI, you can use AWS CFT, you can use AWS CDK, many options, right? So as a DevOps engineer, you decided that your organization will use AWS cloud formation templates. Okay, so what you have done is you have used AWS cloud formation templates, which is called as CFT, and you have automated the infrastructure on AWS cloud platform. Okay, so let's say this is AWS cloud, and you have, what have you done? You have automated this stuff. So any developer who comes to you and tells you, okay, Abhishek, I want 10 EC2 instances. So what you'll do, you'll say that, yeah, using CFTs, I already wrote the script. Now I just need to execute the CFT script for EC2 instances, and your 10 EC2 instances will be generated in no time. Similarly, somebody comes to you with S3 buckets, everything. Okay, so you wrote some hundreds of scripts. Okay, so you wrote some hundreds of scripts, and all these hundreds of scripts are stabilized, and your work is going pretty well. Okay, now you don't have any problems. But what happened all of a sudden is your AWS, okay, the decision that you taken, okay, AWS, your management said that, okay, we were using AWS till date, but due to some reasons, like, you are not happy with the AWS support, or the costing that AWS is the cost that AWS is giving to you, you are not happy with it. So what you have decided is you will shift from AWS to Microsoft Azure. Okay, so what have you decided? From AWS you want to move to Microsoft Azure. Now all these hundreds of scripts that you have written will be of no use, because Again, if some developer comes to you and says that, Abhishek, I would need 10 virtual machines on your Azure platform. Okay, so you cannot say that I have written CFT. You can use the CFT because CFT is very specific to your AWS cloud provider, right? So CFT only belongs to your AWS cloud provider. So again, you have to put all the effort and you have to migrate these hundreds of scripts into Azure Resource Manager. Like similar to AWS CFT, Azure supports something called as Azure Resource Manager. Okay, so you put a lot of effort and again you converted the hundreds of scripts into Azure Resource Manager, and you have again automated the entire process. Okay, let's say you have again automated the entire process. Now, what your organization said is, okay, whether it is Flipkart or any organization said, okay, we moved to Azure as well, and we were not even happy with Azure. Okay, so again, the support with Azure is not good, or you are not happy with the costing. So you wanted to move from Azure. This time you want to move to on-premise. Okay, so that means you want to maintain your own infrastructure. Okay, so on-premise. So what you have done is you purchase your own servers, and on top of this servers you used OpenStack. Okay, OpenStack is used to create your own cloud. Okay, so you created your entire data center, and on the data center you installed OpenStack. Okay, and you have decided that, okay, anybody who comes with a request for 10 VMs or 20 VMs, or for any kind of request, we will say that, okay, we have on premise and we have installed OpenStack, so you will get it. But for that reason, what you need to do is you have to again migrate these scripts, okay, that were firstly on AWS CFT. Now you migrated them to Azure Resource Manager, and now you have to migrate them to Heat templates. Okay, so Heat templates is a way how OpenStack automates the process. Okay, so if you want to automate any infrastructure on OpenStack, you will use something called as Heat templates. So again, you waste a lot of time and you migrated the entire thing to Heat templates. So this was the process that was going on. And this is just an example. These days, what usually companies are doing is they are usually operating in hybrid cloud model. Okay, so what is hybrid cloud model? So any organizations, okay, depending upon the requirements, what they can do is they can host part of their infrastructure on AWS and part of their infrastructure on Azure. Now why is this happening? This is because, okay, this was scenario number one. Okay, so what I explained you here, this is scenario number one. And in scenario number two, there is another option that people are moving to hybrid cloud. Okay, so what is hybrid cloud? Hybrid cloud is a way using which you can create part of your infrastructure on AWS and part of your infrastructure on Azure. That is because, let's say, AWS is giving you good offers, or AWS is giving you good support with respect to the let's say, for example, it is giving good support with respect to the storage services. Okay, so for storage services you have decided to use AWS, and for DevOps related services, for the build related services, or for the um, uh, uh, project management related services, you want to use Azure DevOps. Okay, so for DevOps you want to use Azure, and for the for the storage related services you want to use AWS. This is because AWS is good with the storage services, just an example, and Azure is good with the DevOps related services. So your organization, that is Flipkart, has decided to go with this hybrid cloud architecture. Okay, so now as a DevOps engineer, what you need to do is you need to learn both. Okay, so you need to learn both AWS CFT for writing the automation on AWS, and you need to learn Azure Resource Manager for automating stuff on Azure. And this problem can vary from organization to organization and also team to team. There might be some secure services even for Flipkart, where you don't want to use AWS, you don't want to use Azure, and you want to use on-premise. Okay, so again, for that reason, you have to write heat templates or something. So to avoid all these problems, okay, to solve the problem of learning too many things, okay, to instead of I just gave you an example with two infrastructure resources, that is two cloud providers, that is AWS and Azure. This problem can grow leaps and bounds, right? There can be hundreds of cloud providers. As a DevOps engineer, which tool will you learn? So to solve this problem, what people have come with is Terraform. Okay, so who is addressing this problem? Terraform. And the concept here is API as code. Okay, So what all of the previous tools were called? So here, for example, AWS CFT or Azure Resource Manager, they were all called as infrastructure as code because you are writing your infrastructure as code. But the problem there was, even you are writing your infrastructure as code, you are not manually creating the resources, you are creating the infrastructure using code. So that was good. But the problem was, in the world of hybrid cloud and in the world of multiple cloud providers, so you cannot solve the problem with different options like AWS CFT, Azure Resource Manager. You have to learn hundreds of tools. So Terraform came. Who is Terraform? Terraform is a tool that is developed by HashiCorp. Okay, so HashiCorp came ahead and said that, okay, DevOps engineers don't learn hundreds of tools. Okay, so they said, DevOps engineers, that instead of learning hundreds of tools, just learn one tool, and that tool is called as Terraform. Okay, now, will Terraform solve all your problems or not? That is, I'll explain you. There are some problems with Terraform as well in the future videos, or I already created a video on my channel with respect to Terraform. But the main purpose of Terraform is to solve the problem of learning too many tools, or execution of too many tools. Now Terraform came ahead and said that, okay, if you are a DevOps engineer, what you can do is basically you can create Terraform scripts. Okay, so write some Terraform scripts. And Terraform, what it will basically do is, Terraform will take care of automating the resources, whether it is AWS, whether it is Azure, whether it is let's say this is AWS, this is Azure, and this is GCP. Okay, so as a DevOps engineer, what you need to do is you need to write the Terraform scripts, and Terraform will take care of automating the resources on the cloud provider. So you just need to tell the Terraform that, okay, my provider is AWS. Okay, so once you say that my provider is AWS, so Terraform will say that, okay, give me the scripts for AWS and I can automate the stuff related to AWS. Now you might ask me, okay, so the problem is the same. Even now, if you want to migrate from one cloud provider to other cloud provider, you just have to modify, I mean, you still need to modify the Terraform scripts, right? So in the previous slides, I explained you that if you want to move from one cloud provider to the another cloud provider, the problem is that you have to migrate your scripts. But within Terraform, what Terraform tells you is that the migration is very smooth. Like your organization, if it decides to migrate from AWS to Azure, you need to make some minimum changes, like you need to update some modules, or you need to update the provider details. And once you do that, you can easily migrate from AWS to Azure. Okay, so this is how Terraform solves the problem. And the other thing is, instead of learning too many tools, okay, so you don't have to learn about AWS CFT, you don't have to learn about Azure Resource Manager, and again, heat templates or XYZ tools. You can learn just one tool, and this one tool can take care of creating new modules for you. And just looking at the Terraform documentation, you can write automation for any infrastructure. So this concept is called as API as code. Okay, so what is API as code? So API as code is a concept using which you can automate any provider, whether it is AWS, Azure, or OpenStack, anything, using their APIs. Okay, so what Terraform does internally is, Terraform will talk to the API of Azure, Terraform will talk to the API of GCP, or Terraform will talk to the API of OpenStack. So using which, you don't have to write any code. So once you write the Terraform templating, or you write the Terraform script files, Terraform will convert them depending upon the provider details that you have provided. So in one of the files called provider.tf, you say that the provider is AWS. So once you write the Terraform module, Terraform will convert that script into AWS readable API. Okay, or the API request that AWS can understand, and it executes the action and gives you the result back. Okay, so this is how Terraform is one tool that can automate your resources on any cloud provider. Okay, so this is a concept of API as code. Now when I explained a similar concept in the last class, many people were asking me, what is API? Okay, so many people did not understand what is API. So let me take a moment and explain you what is API. So API is nothing but application interface. Okay, so basically using API, you can talk to any application and you can get the response back. For example, okay, let's take a basic example. You want to talk to Google. Okay, so what is the usual process? You open your laptop. Okay, you open your laptop, and on your laptop you will open your favorite browser and you will type www.google.com. Okay, so once you type this, what happens is you send your request to Google, and you get a browser page, and on the browser page you can search the information related to Google. So this is basically a user interface, right? So this is a way how you manually do things. But whenever you want to automate things, or whenever you want to do things programmatically, so this way is not suitable, right? Because let's say you want to get some information from Google in a programmatical manner. Okay, so instead of logging into your laptop, instead of opening the browser and getting the information from Google, what you want to do is you just want to run a script. Okay, and this script will talk to the Google. Okay, this script will talk to Google, and it executes the action and sends you the result back. To perform this kind of things, what developers have come, okay, whether it is Google or whether it is Argo CD or whether it is any application, what developers have done is they have come up with a concept called API. Okay, so using API, you can programmatically talk to any applications. So whether it is GitHub, whether it is Google, whether it is Flip, I don't know if Flipkart has an API, sorry, or any other applications, what they will do is GitHub will expose their API. Okay, so GitHub will tell you that, okay, instead of manually logging into GitHub, authenticating with me, and opening your browser and going through the flows, what you can do is you can open your terminal. Okay, once you open the terminal, you can use a curl request, or you can use a HTTP GET request, and using this HTTP GET request or curl request, you can talk to my API and get whatever information that you want, and I'll send you the result, right? So this way you can talk to any applications programmatically using the APIs. Okay, so that is the only difference. Either you manually talk to the applications using the user interface, or you talk to the applications using a programmatic interface. So the programmatic interface in this case is called as API. That's the concept of API. Now Terraform uses the same concept. Okay, what Terraform does is Terraform, AWS has their own API, okay, and Azure has their own API. What Terraform has done is, instead of developers directly talking to the APIs, because if you want to talk to the APIs, you need to know some programming language. Okay, sometimes GET requests are easy, but you might want to create resources on it, and you might want to make some post calls. So instead of you writing this calls in Python or shell scripting, what Terraform said is that, okay, we'll actively look at these APIs. Okay, Terraform will actively look at these APIs, and Terraform has written their own modules. Or Terraform has come across, let's say you want to create an EC2 instance on AWS. So Terraform said that instead of you directly making API call with AWS, you can write some Terraform file. Okay, and in this Terraform file, you can go through the Terraform documentation, which we'll definitely do tomorrow. So Terraform will tell you that, okay, there is a module called EC2, and using this EC2 module, you just write bunch of lines, just like you write in English. And what we will do is, once user submits this request, okay, in Terraform file, once you do this, Terraform will receive this request, and it will take your input and it will convert your input into API call. Okay, this is happening at the backend. Terraform will convert your request into API call, and it gets the request back, and again Terraform will send you the request back to you. So as a user, you are not directly talking to the APIs of AWS and Azure, but you are writing Terraform scripts, and Terraform is converting your request into API calls. Okay, so this is concept of Terraform, and this is how Terraform utilizes the concept called API as code. So in tomorrow's class, we will see Terraform live examples, and we will see a live project using Terraform. We'll start with the installation. We'll try to create EC2 instances or any specific stack on AWS, and I'll show you how exactly Terraform works. So what did we learn today? We learned about two concepts. One is infrastructure as code, right? IAC, and we talked about API as code. So infrastructure as code is a concept using which, okay, so infrastructure as a code is a concept using which you can automate your infrastructure. So it can be anything, like you can write your CloudFormation templates, or you can write your Azure Resource Manager, or anything. So all of these things fall into the category of infrastructure as code. Whereas Terraform is a concept which is used to solve all of these problems. Like, Terraform also works on the same concept of infrastructure as code, but Terraform has advanced capabilities called API as code. Like, instead of you writing all of these things, Terraform says that, okay, just learn one language. Instead of learning AWS CloudFormation templates, Azure Resource Manager, just learn one language that is called as Terraform, and Terraform will take care of talking to all of those cloud providers using the concept of API as code. I hope you understood the concept well. And if you have any questions, please provide me the timestamp and tell me, okay, Abhishek, I did not understand the concept here, so that I can make a YouTube short video, or, if it is possible, I can also explain you in the comment section. Okay, so this is a concept which you did not understand. And yeah, your feedback will definitely help me to improve as well. So if you like the video, click on the like button. And if you have any questions, not just about today's class, even in the previous classes, do post them in the comment section. And finally, don't forget to subscribe to our channel if you haven't. I'll see you in the next videos. Thank you so much. Take care, everyone.